2 minutes. Okay, all right. Good morning, everybody. My name is Jai Steven. I'm the Chief Blockchain Officer at Dexentric. So we're going to be talking about blockchain today, though we're not going to be looking at the security aspect. We want to look at blockchain as a technology. Then we are going to put more focus on smart contract programming. So today, take home is going to be introduction to blockchain, about the blockchain OSI model. We'll introduce smart contract. Then we're going to talk about the tools needed to code Solidity smart contract. So welcome everybody. I'm glad to have everybody here to see that a lot of people are really interested in knowing about blockchain technology aside from crypto and its use cases. So this training is going to be in series. Our aim is actually to educate people about blockchain technology, and I've said, very important, what smart contracts are and how they are programmed. So look at development tools, how to set them up, how to set a development environment up. So about us, Dexentric is a blockchain cybersecurity company. We are focused on securing the space and building secure blockchain application for both public and private use cases. We have experienced developers that work with protocol like Hyperledger, that is for private blockchain. Then we also have developers that are really experienced in Ethereum, Solana, and US. And we are also spreading our wings towards other protocols. So we are cybersecurity inclined. Security is embedded in us. So I welcome everybody to being part of this family. And I know that we are going to have a whole lot of fun throughout the series. So we have our communities on WhatsApp and Telegram. My guys are going to drop the group. They are going to drop the group link in the chat. So anybody, in case you're not part of the group, you can join. And you can also follow us on LinkedIn and Twitter. So the link will be shared in the chat. So let's get right to it. Blockchain technology. What is blockchain technology? Blockchain technology has been one of the topics that has been coming up recently because of its use cases, and most importantly, the problem it is actually solving. So blockchain is solving the issue of trust we currently face on the internet. So some of you might be wondering, what trust issue is this guy talking about? Yes, when it was actually created by Robert Kahn, that is Dr. Robert Kahn and Dr. Vincef, created two channels of communication, which is the client and server, and they offered a medium of transmitting information to and fro between client and server, which is the port. This simply means that on the internet, your data is going to be managed by the organization you are signed up with. What if the server of that organization get compromised? Or what if the credential of that server administrator get compromised? What's going to happen to your data? Right, we'll elaborate on that much more later. Internet has been around for more than 30 years now, and information are being shared over EIP and the Open System Interconnect model, that is the OSI model. And this is actually used to standardize communication between different networks. We live in a world that is actually controlled by technological transformation, which is one of the reasons security is a must. We live in a world of client model in conjunction with so many network devices. Even some of our using smartphones, which is internet connected. Our fridge, our gadget, laptop, and so on is connected to the internet. And this actually opens up a focal for cyber criminals. So there are so many ways an attacker can gain access to your organization or personal device. We have moved past the time of looking for external vulnerabilities. Attackers they don't take their time to look for external vulnerabilities alone to gain access. So dedicated cyber criminal is going to invest a lot in learning about environment, learning about the technology you use, they understand how both technology and human works. And they're going to find every way to get that data they want, right? I know some people might be saying, yeah, we have a lot of preventive and defensive mechanism in place that is going to tackle all this attack. Let's not forget that there are a lot of technique also employed by these cyber criminals to bypass whatever security you put in place. It all depends on how valuable the data they are looking for in your environment or in your organization is. And if they cannot get access to that information, they could cause disruption by carrying out the denial of service attack. So with this threat room there, organizations keep using emerging technologies and security solutions to combat this threat. But what if there's a better way of doing this? What if we can fix the trust layer from the foundation level? So right from the start, structure is actually a bit broken, if you must agree with me, and fixing it again, bringing up different fixes might just open doors for other threats. I mean, even ransomwares have vulnerabilities, in case you don't know. Yeah, there are hackers that are dedicated to looking for security issues on ransomware. They call it attribution or hack the hacker. So that's the story for another day though. So your security solutions too are pieces of software that can also be bypassed or that can be vulnerable. And that is why they always advise for people to patch their antivirus system, to patch they use on their PC and the likes. And I'm sure some of us have not even updated our Windows or whatever antivirus software we're using. Please, if you haven't do that, please do. It is very, very important. So what if there's a better way to do things? What if there's a technology that is going to provide a secure way of storing data, and that is blockchain? That is what blockchain is actually bringing to the doorstep. So what is blockchain? Blockchain is actually a digital distributed transaction ledger database with identical copies on the network of multiple computers controlled by entities. And the main reason for blockchain technology and infrastructure is actually to combat the fear of authorities or enterprises having access to your data. Because on the blockchain, there's nothing like central authority. Also, because your data are being distributed across nodes on the network, your data, so now your data might be your DApp, that is your decentralized application, it might be your smart contract and any assets you put on the blockchain. So all data and all those assets are not stored on a centralized server. It is actually shared between all the nodes, let's say all the servers that's connected to the blockchain. So your asset can actually be anything. It can be anything of value that requires accountability of ownership. For example, let's say your money, your cryptocurrencies, your real estate, the record of any kind, your transcripts, your results, your identity, your personal property, and so on and so forth. And the use of NFT has actually made it very, very easy for us to store it in digital format on the blockchain. So another important thing blockchain is that it records and store every transaction that occurs in the network, and it is visible. Everybody can see what's happening on the blockchain. So using Block Explorer, I'm going to actually show us how to do that. You can see every single transaction that has happened in your account. I'm sure some of us know that now. So for Ethereum, we have Etherscan. Bitcoin has their own Block Explorer too. So Block Explorer is an application that gives visibility on every single transaction happens on the blockchain. Blockchain is the technology that aligns Bitcoin, Ethereum, Solana, and other cryptocurrencies. So in simple terms, we can think of blockchain as your normal register. You can add entries or you cannot delete. So think of blockchain like a register. So what makes up the blockchain are actually blocks connected to each other. So blocks as pages in your register. Then think of transaction as entry into that particular register. So your blockchain is your register, block is your pages in the register, then your transaction are entries into that register. Blockchain is not a new technology, right? It's actually built from three different technology. It's a singing of existing technology, that is peer-to-peer network, the private key encryption, and smart contract, which is the program that blockchain actually uses. We have different type of blockchain. We have public blockchain, we have the private blockchain, and we have the permission blockchain. So the permission and the private blockchain are similar. So the public blockchain is a blockchain of large distributed network that run on a native token, right? So it might be Bitcoin, Ethereum, Monero, and the likes. So they are open for everybody to participate at, and their code is actually open source, right? And the team maintains their code. They keep trying to improve on their code every single day. So now we have the permission blockchain. The permission blockchain control roles that individual can actually play within the network. So they are large and distributed system, but they also have a native token, such as Ripple. So their core code may or may not be open source, right? So, and the goal of a permission blockchain is actually to prevent anyone from accessing sensitive information and also deny attempt to make changes to the block. So permission blockchain have strict membership rules and permission. So it's not everybody that can partake in a permission blockchain. The same thing applies for a private blockchain. Private blockchain seems to be they are kind of smaller than the permission blockchain, and they do not have a they do not utilize a token, right? Their membership is closely is closed. All right. So all these three types of blockchain use cryptography to allow each participant on any given network to manage the ledger in a secure way. The need of any central of authority to enforce any rules or any regulation on. So the removal of this central authority from the database structure is one of the important thing and the powerful aspect of blockchain, right? Blockchain creates permanent record and history of transaction, but nothing is really permanent. So the permanence of the record is actually based on the performance of the network, right? In the context of blockchain, this means that a large portion of a blockchain community will all have to agree to change the information and are incentivized not to change that. So whenever you record a data on the blockchain, it is extremely difficult to change or remove it. So whenever someone wants to add a record to the blockchain, a record, or whenever you're adding something or you're saving something on the blockchain, is actually called a transaction or an entry. So whenever you want to do that on the blockchain, users in that particular blockchain network have to validate the transaction. After validation, they verify the proposed transaction before it's going to go. So this is where things actually get tricky, because every blockchain has slightly different spin on how transaction and validation should work, and who can actually validate transaction. So now we are going to look at the blockchain OSI model. So the internet actually uses the internet OSI model, which is the conceptual model that is created by ISO, right? And it has 7 layers. The OSI model has 7 layers, which is the physical layer, data link layer, we have the network layer, the transport layer, the session, presentation, and the like, and presentation, right? So we also have other layers, OSI model, but it's not always there. We have the user, the organization, and the government layer, which has to do with who and how we interact on the internet. And that is for OSI model, right? So this is actually different from the blockchain ecosystem. Blockchain also has 7 layers aside from the user and DAO, then the policy. So we have the physical layer, that's the in the blockchain OSI model. The physical layer in the blockchain is actually the same thing as the internet physical layer. So this layer is where your mechanical, electrical, and other methods are used to transmit bits over physical. We have the peer-to-peer layer, which is the second layer, and this has to do with decentralized peer discovery and how participants communicate with each other. So participants here can either be miners, they can be validators or nodes. Then we have the consensus layer, which is how an agreement, a consensus on the blockchain is how an agreement is being made on the blockchain. So this is where the Byzantine fault tolerance live. So the Byzantine fault tolerance handle block generation and the incentivization mechanism to encourage participation and integrity of your blockchain ecosystem. So in this layer, that's where you're going to be seeing your mode of consensus. You're going to be seeing your proof of work, proof of stake, your proof of activity, your delegated proof of stake, and the likes of them. So this might sound a little bit confusing. Share a little bit of light on it much more later. The next layer is the transaction layer. The transaction layer has to do with individual transaction among blockchain participants. So it has to do with the kind of information or transfer or state updates, contract for, and other activities that's actually happening on the blockchain. So this layer is confirmed into the consensus layer. So we have the state layer, and this layer actually holds the active and confirmed state of all on-chain activity from the genesis block to the recent block. This block is actually the first block that is being created on any blockchain. So the state layer can be also considered memory or storage. That is where you actually agree upon how participants are going to be held in the network. So we have the scalability. The scalability layer actually provides solution to improve throughput commands on the network. Then we have the DApp layer. So the DApp layer is actually the logical layer in which the development, deployment, and execution of smart contracts, your access control mechanism, and the Turing complete state lives, right? So the EVM also decouples this from the consensus layer, while other protocol like are actually unifiable. So that's what the difference between the EVM, that is Ethereum Virtual Machine, to Solana. So we now have the user layer, which is the human acting with the DApp application or the DApp layer. So is that are trying to view or change the state of the network through our transaction or interaction. This layer is where security awareness is important because users have greater responsibility now than ever on the blockchain, because the hacks that happen on the blockchain are different from the ones that happen on the normal internet. So blockchain is a very expensive technology, and security is really, really core, right? So we have the DAO layer. The DAO simply means the autonomous organization layer, and this is decision making, management, and governance are distributed among participants with no central authority. So this is done in various ways, such as token ownership or contract proposal. So then we have the layer, which is the policy layer. So because the blockchain has no border, there's no central of authority, the policy can be considered another layer. So the policy layer is going to that drive the adoption of blockchain, the rules of engagement, and indirect method for the behavior of localized participants using the technology. So that is the blockchain OSI model. Now, let's look at the difference between a traditional web application and a decentralized as I said earlier, everything we do or every activity we carry out daily on the actually sent through an IP packet in the TCP IP model. So an packet is actually the tiniest or smallest piece of data sent over the internet, and this piece of data in a medium called the port. So these ports are actually dependent on the protocol that users use on the internet, or the protocol that users are actually interacting with. So for web application now, we have the HTTP and the HTTPS. So the difference between HTTP and HTTPS is the extra layer of security added on top of it. I'm sure we know that. And we know that HTTP runs on port 80 and HTTPS runs on port 443. So the IP packet actually consists of two components. We have the IP and the payload. So for any information to go through on the internet, it needs the source IP, which is what your ISP is actually giving you. That's your external IP address that you use to browse every single day. Then it also needs a destination address, which is where the web server is actually located. So web application use this client server model to serve users. So a traditional multi-tier web application is going to use CSS, HTML, and JavaScript to render its front end for the client. Then its backend infrastructure can now be written in backend technology stack like LAMP, that is Linux, Apache, MySQL, PHP, or Main, that is the MongoDB, Express, Angular, and Node.js. That's for the front end and backend developers. So the web application also uses an API, which is the application programming interface. The API of functions that allow application to access data and interact with external software components, operating system, and microservices. So web application use API to fetch your data from the database. But when it comes to a decentralized application, it runs on a peer-to-peer network of computers. It doesn't use the client server model, right? It runs on P2P network. So that front end still use the same exact technique to render the front end like the traditional web application, that is your CSS, HTML, and JavaScript. But instead of calling the API, that use the smart contract to connect the blockchain. And that is just the difference between a web application and a DApp application. So we have a smart contract a lot. What are they? What did they do? How do we write them? Let's look at. So smart contracts are just like your ordinary contracts, right? Smart contracts are ways, or it's just a way. Okay, no, let me just contracts generally now are ways of reaching consensus or agreement between people. So this same principle is the one employed by blockchain to solve common issues and at the same time minimize the needed trust. So smart contract programs are Turing complete, which means that they act like a normal program. They only execute when some set of predetermined condition is being met. So today we are going to be looking at Solidity smart contract, which lives on the blockchain, on the Ethereum blockchain. And one of the importance of this smart contract is the elimination of third party in reaching an agreement, right? You don't need to a central party. So what they actually use is a consensus mechanism. So we have the consensus mechanism is what actually makes them to be able to come into agreement on what's going to happen, how transactions are going to be carried out on the blockchain. So we have different type of consensus mechanism. We have the original consensus mechanism of the blockchain, which is the proof of work. Proof of work use computational resource as a mode of consensus, right? That means that if you want to be part of the proof of work blockchain, you need to have a lot of server, you need to have electricity, you need to have light, and you need to have your server room has to be chilled. You need to spend a lot of money. So I know some crypto would have heard about the Ethereum merge, which means that in proof of work now, we are now going to be using proof of stake, right? Proof of stake is also another type of mode of consensus in the blockchain. But instead of using the computational resources, proof of stake actually uses cryptocurrency incentive as mode of consensus, which means that you can join a proof of stake blockchain, you need to have sort of cryptocurrency, right? So it depends on the amount of stake blockchain is actually asking for. But you need to have that particular amount of cryptocurrency to be part of that blockchain ecosystem. So we have consensus mechanism. There are a lot of them actually. We have Byzantine fault tolerance, we have proof of activity, delegated proof of work, and the likes of them. So smart contracts in the Ethereum platform are stored in the Ethereum blockchain and executed by the Ethereum virtual machines. So the Ethereum virtual machine is just a decentralized runtime environment for building and managing smart contracts in Ethereum. So for any function or program to go through, a network of thousands of computers have to process action. So whenever you're sending cryptocurrency from one wallet address to another, it actually goes through network of thousands of computers, validates that transaction to confirm that transaction is true before allowing it to go through on the blockchain. Smart contracts are actually compiled programs. They are compiled into bytecode, which is an important feature of the Ethereum virtual machine. So for every node in the blockchain, they need to execute the smart contract using their Ethereum virtual machine. So, as said earlier, your information is being shared between different nodes, thousands of nodes in the blockchain network, which means that every node is going to hold an updated ledger of every transaction that occurs on the blockchain. So your node is just like your server or your laptops that is connected to a blockchain network. So more on Ethereum virtual machine. Ethereum virtual machine is the one responsible for executing a contract with the rules pre-programmed by the developer. Ethereum virtual machine is the one that is going to compute your data through stack-based bytecode, whereas your developer is the one that writes the logic, the smart contract in high-level languages such as Solidity, we have LLL, we have Viper, we have Serpent, we have on, but for this training, we are going to be looking at Solidity alone for now. Another important thing about smart contract is the cost for smart contract is the cost for the contract instruction to be stored on the blockchain, right? The cost to do expensive computation, the cost to send messages. This transaction or this activity that you're carrying out is actually not free. You have to actually pay for them, which is the difference between the public blockchain and the private blockchain, right? Private blockchain such as Hyperledger and Corda you do not pay for any transaction, right? It's actually free. But for blockchain such as Ethereum, you need to pay for your transaction. In Ether, okay, more accurately, you need to pay for your transaction in gas. So gas is actually the price paid by the Ethereum account that make any contract transaction or uses the contract. And for every transaction, it has a limit parameter that determines the limit of gas that you can actually use in the transaction. So smart contract lives in the blockchain, which means that every in the Ethereum blockchain stores a copy of the smart contract code publicly, right? Which means that your backend, the backend or your block end is actually visible to everybody, which can actually be a security issue for smart contract that are not written well, smart contract that has bugs in it. So we sure have heard about a lot of hack that is happening in the crypto space now, and most of this hack is due to smart contracts, or most of the time social engineering attacks too. But the hack that actually has to do with um, a lot of cryptocurrency, a lot of Ethereum or Bitcoin and the last have to actually do with the smart contract, vulnerabilities in smart contract. So on the internet, we know that there are several issues that comes with the use of your normal virtual machine and the use of different programming language or computer code in general. The same rule still applies to Ethereum in general. So the problem here is that smart contracts are cool that handle money, right? And if they have bugs, money can actually be stolen away from your smart contract, or they can even be locked forever. You will not be able to access it again because it has actually happened in the past. If we look at the first hack, which is the DAO attack, where it was possible for an attacker to wipe all Ethereum stored in the smart contract, and a hard fork had to be done to recover the Ethereum back. So this act actually created a split in the slot DAO, where some people are of the opinion that the blockchain should not be reversed. They need to pause. It's going to. So it's just what they feel about the hard fork that they actually did. So this actually caused a split in the Slocky DAO, and that is why we have different type of Ethereum. We have the normal Ethereum and we have the Ethereum Classic. And because of these bugs and this vulnerability in smart contract is one of the reasons why developers need to learn how to write non-buggy smart contracts and how to optimize gas, how to limit transaction, how to look for vulnerability in their smart contract, and how to secure their smart contract. Which is very, very important. So the reason why we are going to be using Solidity is because Solidity is actually one of the most used programming language or most used contract-oriented programming language. Let me put it like that for smart contract development, mostly in the Ethereum platform. Solidity is actually statistically and it is compiled to Ethereum bytecode that is deployed by the Ethereum virtual machine. So for the purpose of this training, we are going to write our first code in Solidity, which is one of the most widely used language in the Ethereum platform. But before we do that, we need to download an important tool. We need to set up we need to actually have to set up for our environment. So let's go to that. Yeah, so in this introductory class, we are going to look at a couple of tools that we need to have installed on our laptops, right? And by the end of this class, we should familiarize ourselves with those tools. So we are going to learn how to interact with different blockchain, how to connect to different blockchain network, how to get reliable information about transaction using your block explorer. So the prerequisite for this whole training, we are not going to go in depth today. We're only going to scratch the surface. The prerequisite is not going to break a bank. The thing you're going to be needing for this training is your Chrome, your Firefox, or any other browser you use. The internet connection is very, very important. So the first thing we want to look at is your MetaMask. right? Your MetaMask is actually a that can secure and store private key and connect to different blockchain. So to download your MetaMask, so I have an environment here called Zion. So is actually developed by Albon. Albon is a blockchain security company too, right? So because of the complexity of installing the tools when it comes to Albon actually came up with their open source end-to-end blockchain security testing and development tool. So you can head over to zion.org to download Zion. Um, Zion.org. So you can run your Zion on your Mac if you're using a Mac using your VMware, and you can also use VirtualBox. You can use VMware, but the hardware requirement that's for Mac is 16 gig RAM. So your Mac has to MacBook Air, either is M1 or M2 with 16 gig RAM, then 512 gigabyte storage, right? Or if you're using your normal PC, your PC has to have minimum of 6 core CPUs, right? With virtualization enabled, then you need to have like 16 gig of RAM and 5 gigabytes of storage too. So this is Ion. If you don't want to start installing those tools, if you don't want to start creating your own environment yourself, you have this environment already. It's made of all the tools you're going to be needing is actually here, right? So you just download the version of the kind of computer you use and we get right to it. So first thing you need to do, if you're going to be using Zion, you don't need to start downloading MetaMask. Everything is there. You just need to set it up. Everything is here already, right? So when you install MetaMask, it's going to automatically open up the setup page, right? So we just hit on begin. Then you are just going to walk through installation wizard. So you click on agree, then you'll be asked to create a wallet. Yeah, create a wallet. Then it's going to ask you to input a password. Just input the password that I can remember. Right. I have agreed. Continue. I want to save. All right. So should in case you're going to be using your MetaMask to actually store real Ether, you need to create a strong password for it because your password you create is what MetaMask is going to use to encrypt your private keys, right? Which will be a straight link to your Ether, and you don't want that. So use a strong password if you're not only going to be interacting with testnets. So we want to click on next. So the next thing we want to do is we want to back up our phrase, right? This now. We can do that later because we are just going to be using this MetaMask for development purposes. So we don't need to do that. We actually need to back it up. So I'm going to do remind me later. And yeah, we have our account set up already. So on the blockchain, there are different kind of network on the blockchain. If you've never worked with blockchain before or blockchain wallets or software wallet before, the first thing you're going to notice is that there are a lot of blockchain network. I'm referring to Ethereum blockchain network now. So this different blockchain network is the equivalent of having multiple databases. So we have the mainnet, which is this guy here, Ethereum mainnet, and we also have the testnet. So if you click on this mainnet here, you can click on show and hide testnet. You want to show it here, go back. So from here now, you can see that we have a lot of a lot of testnets that we can use to carry out our development. So the next thing we want to do is, we want to request for free, because as I've said earlier, for every transaction and everything you actually do on the blockchain, right, you need to pay a gas fee for it. Right, so we'll just go here, we'll type, so we're going to be using Ropsten testnet for now. Ropsten test network. So we are going to request for 4 sets. So 4 are test ethers that you can use, blah, blah, blah. Let me see. Which one should I use? Okay, I think this is fine. You can use this for go-find.com. So the next thing you need to do is just copy your Ethereum address here, come here, paste it in here, and click on Give Me Ether. Address limits, please retry. Okay, I've actually tried this once. Let me see, but I don't have any recent test. Okay, sorry guys, just give me a minute. Let me open this guy up. I think I have one set up in here. Okay, store. Sorry, give me a minute. Okay, so I have 10 Rosen here. So I am going to be using this one for now. I think I've requested with this guy before, but I don't know. You say address limits. I have to retry again after 15 hours. If you try your first try, giving you 10 Ethereum, you might need to wait for 24 hours again before you'll be able to do that. So I think that's the reason why it's telling me address limits, but we can continue. So as said earlier, everything that has happened on the blockchain is visible, right? So if I send a transaction from it, for example, now, let me open this guy. So you have multiple accounts on your test network. So if you want to create another account, you can go here. Okay, I actually have 2 accounts created already here, right? But if you want to create another account, you can just click on this account, put in your account name, say test account, and click on create. Now, let's assume this is another wallet address and I want to send Ether from here. Let's click on send, paste in the address that I want to send Ether to. And let's say I want to send 3 Ether to. Okay? So we'll click on next. Then it is going to give you the estimated fee, which is the gas I've been talking about that you need to pay to carry out a transaction network. So all you need to do is confirm. That's if you're okay with gas fee, confirm, because gas fee actually changes every second. So yeah. So now this is pending for now. We can click on here, just click on here, then click on the status. So you see view on Block Explorer. So you can click on view on Block Explorer. So Block Explorer is going to give you the details of your transaction, the status of your transaction, the block at which your transaction is actually added on, right? Then the last time seen, where you're sending your Ether from and where you're sending your Ether to. Block Explorer is actually very, very important when it comes to blockchain forensics, because most of the time, yeah, this is what you're going to be doing. To be monitoring, you are going to be monitoring transaction. You're going to be checking links between transaction, where this person has sent money to, the kind of address, the kind of how the money has sent to different accounts and the likes of them. Right, so blockchain explorer is really important. So the status of our transaction is actually success, which means that our transaction has gone through. If you click on MetaMask, okay, yeah, it has gone through. If we check the other accounts, we see that we have 3 Ropestone ETH in here, right? So that is how to actually view the transaction or view every transaction that you've actually carried out on the blockchain, right? Using Block Explorer. So if I go to each, you can actually view, let me just take this out. You can view transactions for different kind of blockchain. It's either you're viewing for Ethereum or you're viewing for the Rosen testnet, the Kovan testnet, Rinkeby testnet, and the likes, right? So if your transaction that you set is on Rosen testnet, all you need to do is just click on Rosen testnet. It's going to open rosen.etherscan.io, then paste in your address here or your transaction hash or the block number or token and the likes of them. So let's move on. So a user actually carry out an action on our DApp application, that's our decentralized application. It is actually recorded on the blockchain, and this action is called a transaction. So this transaction is not going to be immediately added to the blockchain. Instead, it is going to be sent to the network where it's going to queue with other pending transactions, and it's going to wait till it's confirmed as a valid transaction by the miners. So once the miner confirms your transaction, it is now going to be added to the blockchain, and the information is going to be updated. So Ethereum network represents hundreds and thousands, even millions of servers, right? But we don't have thousands of servers just lying down around for development, and we don't want to wait on external servers every time you need to test during the development. So there is actually an environment called Ganache that is going to help us simulate our own Ethereum network, right? It is a standalone application that can create an Ethereum testnet network on your own workstation, right? So to install Ganache, you just need to head over to Truffle Framework. So just click on Truffle Framework download. So you go here. No. So okay. You can just search for Ganache download. All right, so this is Ganache, just click on it. So Ganache has different versions. Is either you're using the UI version or the terminal version. So the terminal version, you can actually use to install it. But if you need the UI version, you can download for your OS, for different kind of OS here. Right, so I have it installed here already. Click on Ganache. And as I've said, this is one of the important of, okay, no, this is not it. Okay, so that's Ganache CLI. So I want Ganache UI, right? This is it. So that's one of the importance of this Zion OS. So Zion OS is going to make your life easy. You don't need to do any installation again. All you do is start developing, start testing, just start working, right? Start creating your decentralized application on the likes. So to use Ganache, you just want to go to create new workspace. If you create new workspace, it's going to load in a minute. Okay, so you type in the name of your workspace. You can just do test. Then you can go to account and keys. How many accounts you want to create, right? No, we don't need this. So how many accounts you want to create? How many, what do you want the accounts to have? Let's say you want to create 10 accounts. and we have the account. Oh, okay, yeah. So we want the balance to be 10, and we want the total account to be, let's say, 5 accounts. So you can just click on start. So starting this is going to create three different addresses for you that you can use for development purposes, and the balance of each address is going to be 10 Ethereum. Right, so you can use this for development purposes. So let's move on. We're going to actually in a minute, but before then, let's move on. So apart from Ganache, there are other tools we need to install, which is already installed in Zion, but we need to talk about them. The first one is your Node.js. You need to install your Node.js. Node.js comes with npm package in it, right? Which means that whenever you install your Node.js, you have your npm. So you can go to this address here, nodejs.org.n.download to download Node.js, right? So after you've downloaded Node.js, you can just go to your terminal. Let me make this bigger. Check this out. And do node-v to get the version of Node installed on your virtual machine. Then you can check the npm version too. It's going to give you your npm version. So once this is done, the next thing you want to install is your truffle. So to install truffle, you can just do npm. You can use npm to install truffle. Install -t, then truffle. But I have truffle installed, so I don't need to start installing it. If I do truffle --help, all right, so I have truffle installed already. So the tool you want to install, that is if you're not using Zion OS, is Go Ethereum. That's your get. So your Go Ethereum is one of the 3 original implementation of the Ethereum protocol. It is like the underlying for Ethereum blockchain, right? So to install get, you can just go to your browser and type in do get installation. So it's going to bring you, then you can now install get for your own OS. And bam, that is it. That is all we need to install to start developing on Ethereum blockchain, right? To start developing, writing your Solidity codes and the likes. So let's move on. So yeah, we can do get help to get to know the kind of command we can run with get. So get help is going to give you all the switches you can assign with get, right? So then you can use get roasting accounts new. So if let me just show us how to do that here. So I have get installed already. So if we do get -help, it's going to give us all the switch we can use with get, right? Then if I want to create a new address with get, all I need to do is get, then I need to specify the kind of network, first network I want to create. For this purpose, I want to use Robston, then account, create, right? Yeah. Account, okay, new, yeah, new. So it's going to ask you to put in password. I want to add a dummy password. And create a new address for you, right? So to check the list of addresses that we've created on Get, we can Roaston account list. So it's going to give us, yeah, it's going to give a list of accounts we have created in with our, right? So That is how to set up kill, or get. So the next important tool we want to look at, which is very important, is our remix. So the very first time you open up your remix is going to actually show some pop-up for you. Okay, so let's use this guy. So it's going to show some pop-up for you. This is not the first time I'm actually launching it. That's why it's not. But just feel free to accept it if you have any concerns about, if you don't have any concerns about their privacy violation and the likes. So Remix ID is actually a powerful open source tool that helps you write your Solidity smart contract straight from the browser, right? So it comes with compiler for different Solidity version, which is here, sorry, which is here. We have compiler for different Solidity here. So no matter what your Solidity version is, you can still connect it to the MetaMask and to the blockchain. So Remix actually store its file in the local storage of the browser, and your address can either be in HTTP or HTTPS. So you need to confirm, right? If your address here is in HTTP and you're trying to use HTTPS to gain access to your Solidity file, you will not be able to. It's going to create another new environment for you. So maybe after a while, you can't find your smart contract again or remix, just check the protocol. Make sure you're using the right protocol. So you can also the address of your smart contract. So remix come in different themes. You can come here. I think you can change the theme somewhere here. Yeah, here. So if you are the lights kind of guy, you can change it to light. But me, I like dark or black. So I'll go with the black. Everything in Solidity is actually a plugin. Solidity Remix, sorry about that, I mean Remix. Remix is actually a plugin architecture, right? Pretty much everything on Remix is a plugin. All the functions are done via plugin, the compiler, the deploy and run transaction, which is this guy here. This is the deploy and run, this is the compiler. Everything, they are plugged. So the blockchain connection is also a plugin, right? So immediately you start Remix, your plugin is going to immediately start with your IDE. And if you cannot find your plugin, you can just click on the plugin icon here and add whatever plugin you want to add to your Solidity smart contract. So you can activate plugin from here, right? Solidity compilers come in different versions, as we've said, and you can actually switch from one compiler version to another. So as earlier again, Solidity is a cost-effective programming language. And sometimes as developer, you might be required to actually work with different versions of Solidity. New compiler versions are actually published very frequently on Remix. So some very popular projects are actually using the old version of Solidity. It is very normal to find Solidity code written in outdated version, right? Then another thing you want to make sure is you want to make sure that you auto compile this. So the reason why we want to do is we want our smart contracts to compile as we write, so that in case we have any bug, we are going to see it. For example, this is just a contract. Let's say I want to create another. Let's say I want to create a state variable of address, and I put in the visibility here. I want to call this my address. So in case I forget to add my semicolon, it is going to tell me that, okay, you haven't had semicolon in here. And that is why this guy is important. If we take this out, now, I think this is because okay, all right. So if we take this out and we do it like this, it's not going to be out automatically. So it's not going to show us an error. So it is important to always to always activate our auto compile in Solidity so that we can always get error as we write our Solidity smart contract, right? So to create a new file, all we need to do is, let me just put this here. Come here, just click at this icon here, and you can now call your contract anything. You can call it my first smart, let's see, my first smart contract, like this, right? So that's how to create a Solidity smart contract. So in your default workspace, I'm sure you are seeing some dummy files, but we don't need them, right? So you don't need them. You don't need to check anything. So they're just dummy contract that is actually inside this contract, then script for compilation and the likes. So that's what's in there. So let's start writing our first smart contract. So first, whenever you want to write a smart contract, the first thing you need to start with is your license identifier. So it goes like this: SPDX license identifier. So and I'm using unlicensed. So this is your software package data exchange, right? That's your SPDX. Identifier is there to just clarify how your Solidity smart contract is going to be made available, right? If you decide to actually make it available, right? Smart contract transparency and trust actually benefit from the source being published. And sometimes it's not 100% clear under which license the source be in the wild. So the SPDX identifier is optional, but is actually recommended. So there are different kind of SPDX identifier that you can work. You are working with MIT or GPL3, but for now I'm going to be using sense. Then the contract itself starts with a pragma statement. Pragma Solidity 0.8.0. So yeah, the pragma statement tells the compiler about the code. So in our case, we want to tell the compiler that the code we are trying to write in the Solidity programming language should use version 0.8.0, version of the Solidity smart contract. So immediately we change it to this guy. If we go here, we'll see that it's on 0.8.0 in here. So you can actually use other Solidity version. It doesn't matter. The only difference is the syntax for the newer version is actually a bit different from the older versions, right? So the 0.8.0 is called the semantic versioning, or the SEMVer for programmers. I'm sure you guys know what I'm talking about. So the first number, which is the 0 here, stands for the major version of this package. Then the middle number, which is the 8, is the minor version, while the last 0 is the patch level, right? So we have the major version, the middle version, and the patch level. So to declare a contract in Solidity, right, we have to use the contract key, the name of our contract. So it's actually a common convention that name actually follow the name of the file. That is the name of the file you created here. Most times, yeah, but it's not necessary, right? But so in our own case, we want to actually use our contract name. So we do my first SC, then again. All right. So we have a set of opening brackets, which is the curly braces in here. And sometimes you might need to add comments, right, to your programming language, I mean, to your smart contracts. It's very, very important so that it's going to help you or help people that does not understand Solidity smart contract know what you're actually coding. So for here, I'm going to go write my first contract. There are actually two ways that you can use to write comments. Either you're doing it this way, or the second way is like this. My first smart contract. do it like this. Sorry. Yeah. So is either you're using this double slash or you're using slash and asterisk. So that is how to put in your content into Lady Smart Contract. So the next thing we want to do is we want to add some content to our smart contract. So we are not going to go to the basics of Solidity, the data structure and the likes today because our time is also actually up, but I'm going to try to just make it fast and to wrap things up quickly. But I just want to like give us an example of how we can add content to our Solidity Smart Contract. So we have different kind of variables in Solidity Smart Contract. We have our variable, we have our public variable, we have our local, we have our state variable and local variable rather. So to declare a state variable are variables that's actually stored on the blockchain. And as I said, we have two types of variables, state and local. The local is actually, and the local variable actually lives in a function call. We're not going to talk about that today, maybe in our other classes. So to declare a state variable, so it depends on the kind of state variable you want to declare, right? But for now, we want to declare a string state variable. So we put in the word string, public, then we want to call it my string, and want to set it to hello world. So we set our string to public, and Solidity is going to automatically generate a getter function for it, right? So you see that in a minute, just a second. So immediately you have this, right? First thing you want to do is SPDX license identifier. Why is it giving me error here? I should have not provided any source file before publishing, adding the statement, blah blah blah. This is not the best. Continue. So head over to deploy and run. So if we deploy the smart contract, so we can actually deploy this smart contract using different methods. So right now we are using the JavaScript virtual machine, right? We can use this contract using our injected provider, which is going to be our MetaMask. So if I click on this, it's going to automatically pop up. Okay, this was the issue I was having with this guy yesterday. Okay, so just a minute. Let's copy this contract. Let's do this guy. Okay, so I have it here also. So let's head over to deploy and run, and let's change it from remix to injected provider MetaMask. So it is going to automatically pop our MetaMask for us. Okay, let me rerun this guy. Just a minute, guys. So it happens like that. So if you're trying to connect and it's not popping up, all you need to do is just reload it. Sorry. Then head over here, change it from remix VM to injected provider. So it's going to automatically pop up our MetaMask, right? And it's going to tell us that do we want to connect our MetaMask to our remix ID? We want to click on this, we want to click on connect. So our code, our remix is actually connected to our Web3 provider. What we want to do is, so I don't actually have any Ether here, so our transaction might not go through. So I want to copy this address. I'll go back to my other MetaMask that has Ether on it, and I'm going to send some Ether to the other one. So let's go to the one that has 7 HR, okay, 6 point something. All right, so let's paste in the address. Then let's say we want to send to then next. Then let's click on all right. So this is okay. Let's see if we can speed this up. So that's yeah. Let's speed it up a little bit. Our transaction to go through. Once it gives us success, we'll have HR in our MetaMask. Just a minute. Okay, all right. So let's go back to our other browser. We should have some ether in here. Okay, yeah. So we have 2 ether in here. So now, everything you do on the blockchain, right? So there are 2 things you can do on the blockchain. Is either you're making a transaction or you're making a call. So when you're making a transaction, you are trying to alter the state of the blockchain. That means you're changing something or you're adding something to the blockchain. When you're making a call, you're just trying to retrieve what has been saved on the blockchain. So, and they actually cost differently. Some calls are actually free on the blockchain, while some calls are, we are going to pay a little bit of gas. But transactions are always paid for. You need to always pay for your transactions, right? So if we click on deploy, going to pop our MetaMask and tell us that we need to pay some certain amount for this transaction to go in. We are going to see the total amount of and roasting it for our transaction to go on. So what we need to do is just click on confirm. So in a minute, we're going to see our transaction added here. So we can also verify this smart contract that we just created here on the roasting Etherscan, right? You can see that it's still pending. In a second or in a few, it's going to actually go through and we're going to success. So yeah, our transaction has been confirmed, right? And our first contract here, right? So if we click, as I said, whenever you create a public a state variable for it, it's going to automatically create a getter function for you. The function is going to allow you to get the value that is being set for whatever variables you're creating on the smart contract, right? So for here, I declared my string hello world. So if I click on my string, it's going to bring hello world, to return hello world back. So we can actually add more. We have, so this address is one of the important data type in Solidity because that's what actually facilitates sending of Ether and the likes. So we can do, and we know that our address is actually 20 bytes long. So let's call it my address. So let's say we want to set our address to this guy here. Let's copy this. Let's paste it in here. So if we deploy the smart contract to give pay for it, normal, right? So it's going to still pop up, tell us to confirm the gas fee we are paying for this particular action because we're actually saving this particular address to the blockchain too. So we're going to confirm. Yeah, and it's going to go through in just a minute. We should see our transaction added here in a minute. Why is it taking? Okay, yes, we're done. So it's also going to create another getter function for us, right? If you click on this getter function, it's going to return the address, this particular address that we imputed in here, right? So this transaction on using MetaMask actually take a while, and sometimes it's really fast, right? But we don't to always wait for our transaction to mine before we develop on the blockchain. It's actually stressful, and that's the major issue with mining on mainnet and testnet, it takes a while before completing, and it's not convenient for developer like us, right? So there are other ways we can actually use to test our smart contracts, right? So, and that is why we have our JavaScript virtual machine. So JavaScript virtual machine is a simulated blockchain environment that only lives in your browser. So no matter you use, it is there. As long as your tab is open, it is going to be there. If you refresh the page or maybe accidentally intentionally close your remix and you reload it again, it is going to be there. But the only we are going to have is, so let's change this guy to remix VM. So this is our JavaScript virtual machine here. So now let's deploy. If we deploy this guy, it's going to immediately give us our deployed here. So if you reload this guy, just a minute, guys. So if you reload this guy now, right? So the only problem we're going to have is we always need to immediately we reload or we hello guys. Sorry about that. Can everybody confirm they can hear me? Okay, cool. All right. Sorry about that, guys. My network actually went off. Actually, they took the power, so my network went off. So yeah, that was right. As I was saying, so that's the only issue we are going to be having with our um JavaScript virtual machine, right? But aside from that, it's actually really fast. So immediately we click on deploy, we're going to see that in less than a second, we have our transaction here. And we also have our getter function that's going to give us the value that we set for our address and our string If we click on address, it's going to give us our address. If we click on our string, it's going to give us our string, right? So, and the good thing about Java VM is that you don't need to actually set up anything, right? You don't have to wait for transaction to get mined. You don't have to set up anything. It's actually a very good way to start developing. It's a good way to start developing. So, and the only bad thing is that once you reload it to your compile contract, you might have to need to compile again, right? So it's non-persistent. That is the only issue with JavaScript VM, but it's really, really cool. And for this class, that is what we're going to be using. But let's also look at the other options we have. So the other options we have is using Ganache, right? Earlier, Ganache is like a local blockchain on our workstation. So for development purposes, is either you are using Get, that is your Go Ethereum, or your Ganache CLI, right? For development. So we can install Ganache in .com/Ganache. I've told us how to do that earlier, right? So if we want to use Ganache for our development, so is either we are using the GUI, which is this guy, which is connected on 7545, or we are using the CLI. So let's use the GUI first. So here, we are going to connect it to Ganache provider, right? It's going to ask for our JSON RPC endpoint. Our RPC endpoint here is this particular IP address. That is our local host, then on port 7545. So all we need to do here is come back here, click on this guy, and change this to 7545. So immediately it's going to give us the first in our Ganache. If we click on our Ganache here, it's going to give us the first address, that is 0x0x27, which is the same one we have here, and it's going to give us 10 Ether, which is the amount of Ether we actually specified, right? So, so let me change this back. Let me close this guy. So we can actually use the G. Let's clear this out. We can use the CLI Ganache. If we do Ganache CLI, Ganache CLI is going to create a list of accounts for us. It's going to create 9 accounts for us, give us a private key, and it's listening on port 8545. So it's either by using the GUI or the CLI, right? So if we want to use the CLI version, let's go back here. We see all we need to do is go back here, click on Ganache provider, then it is automatically going to pick up the first address in here. 0x5b, right? 0x5b. Okay, I think it's actually, yeah, we have all these addresses in here. One, I can't I see this first guy. Okay, so you just start your Ghana CLI, it's going to create list of address for you. And if you click on OK, right, I see why. We need to find a way to change this. So let me reload this again. Just give me a minute, guys. So this is what we're trying to achieve here, right? So yes, our contract is back on our contracts. Then let's click on run and deploy. So now I want to deploy on Ganache provider. Yeah. So it's going to give us the Ganache JSON RPC endpoint, which is the same thing as the one we have here. That is 8545. So what we need to do is just click on OK, and automatically it's going to give us the first address, that is D4 0xD4, and we should see, okay, yeah, we are connected now, which is this guy. So we can now start writing our smart contracts, start deploying them. This is going to be fast also. All right, this is going to be fast. So we can start writing our smart contracts, start deploying them, start testing and the likes, right? So you can use whatever method you see fit for you, that is going to be easy for you. In the course of this training, we are only going to be using the JavaScript VM because it's fast, and it already has dummy iter that we can use to create transactions. So this is where we're going to call it a wrap for today. I'm sorry I took too much time. I was supposed to actually finish by 11. I'm sorry about that. So by next week, we are going to look at the basic of Solidity. That is its data structure, right? From there, we explain few concepts in Solidity, and I'm sure you guys are going to find it really, really interesting. All right, thank you very much, guys. Let me just do something so that everybody can ask their question. Okay. All right. So guys, if you have questions, you should be able to ask your questions now before we call it a day. Question, guys.
Hello.
Hi.
Hello, good morning. Good morning,
Good
Mr.
morning.
Steven. Yeah.
Morning.
How are you? Please, my own question is just how can I get, will I be able to access this record?
Okay, so what I'm going to do is I'm going to download it and share drive. Then I'm going to share the link on the group chat, on the community group chat.
Okay. Thank you very much.
Yeah.
Hello, good morning, Mr. Steven.
Good morning, sir.
Thank you for the awesome section. It was enlightening.
Thank you very
so
much.
I have a quick question.
Okay.
So it's related to blockchain forensic.
Okay.
So is there can you do a cross-chain block explorer?
Cross-chain block explorer. No, I don't think so. So for every protocol has their own block explorer. So I don't think there's any cross-chain block explorer for now.
All right. All right. Thank you.
Thank you very much.
Good morning. Good morning, sir.
Good morning.
Good morning, everyone. I think based on that question he asked on what's it called, block explorer and cross chain for it. I think Polkadot is like trying to come up with such idea though.
Oh, okay, but has it been implemented yet? Okay, guys. So this is a community. You guys should not look at it as a training. We are just having a training and the likes of it. You can actually see what's on your mind here. You can ask any question, whether it's stupid or not. We are a family in this community, and that is the essence of this community. So you can ask any question at all. Right? On the group chat, we have professionals on the group chat, both cybersecurity niche, blockchain niche, forensics, and the likes. Right? Anything that has to do with security and development, we have guys on that group chat. So feel free to ask questions on the group chat or on the training, and feel free to hear your thoughts. We want to know your thoughts. We want to know what you feel about the platform, right? Should in case you have anything you feel we can do to improve the platform, or to improve the training, please don't keep it to yourself, right? Please always hear your thoughts out. Okay. All right. So so this is where we're going to call it a day today. All right, somebody's raising up their hands. Please, Joseph, ask your question. You can go ahead and ask your question. You can unmute yourself and ask your question, Joseph. Okay. All right. So, in the absence of no other question, this is where we're going to be calling it a day today. In case you have any concerns, any other question, you can always drop it on the group chat and we're going to attend to it. I hope you guys enjoyed or gained a little bit of insight on what blockchain technology is, smart contract is, and how to actually program, and the tools you can actually use to program Solidity smart contract. It's going to be really, really interesting. We are going to build a lot of cool stuff in this training. Just be consistent, be active on the community group chat, and
hello, good morning. Sorry for. Can you hear?
Okay, yeah, I hear you now.
Can you hear me now?
Yes, I can.
Yeah, I must commend your training. It's quite pragmatic. But my own observation is that I remember when I did a training on cloud IoT development. I don't know if we can learn a little from it. I would have loved that we have two kind of segments. The first segment has to do with the theoretical aspect, the sequential process, defining what we are supposed to see, how we are going to get there. You know, the first stage, what is this, what is that, what we are going to do. Then once we are done with that theoretical aspect.
Okay, so yeah, I get what you're trying to say. I get where you're coming from.
Of course, everyone will know that the next stage is the pragmatic aspect, which has
hello, Joseph, you're breaking. Okay, I might have to mute you. Okay, so I understand what Joseph is talking about. True. When it comes to technology, right, you really need to understand the basics first, right, before you even go to the practical part of it. But the truth of the matter is, blockchain is very wild, very, very wide. You understand? And talk about the theoretical aspect of blockchain alone is going to take a while. So what we're going to do on that regard is that I am going to drop a list of content that you can go through. Maybe we can also have a session on the theoretical aspect of it, the foundational aspect of blockchain, so that everybody will be on the same page, so that we don't always only familiarize ourselves to the practical aspect or the programming aspect of it. We should also know the nitty-gritty behind the whole technology, how to should in case we've been hacked outside, you understand? Yeah. So we're going to create a class for that. Yeah. Me and the team are going to work on that. And I'm all drop some content, because we've actually had a session like that before when we did our foundational course. I'm sure you're not here, Joseph. That's why you're asking this question. I actually created a material that has almost everything you want to know about blockchain. So I'm going to share that slide again. Then maybe one of these days we'll go through the slide again, and we'll also go through the security aspect of blockchain, then before we proceed on our contract programming and the likes. So yeah, I get it. We are going to work on that. Thank you very much for some observation. So I saw the question on the group chat. What's the difference between hard hat and remix? The difference between hard hat and remix is hard hat is actually a CLI that used to deploy or compile your smart contract. Remix is actually a GUI. It lives in your browser. So is either you use add art, is either you use add art, or you use truffle, or you use brownie and the likes for your CLI or your Ganache CLI. Okay, no, Ganache CLI is actually creating accounts for you and the likes. So you can you can use those ones for your CLI deployment and compilation of your smart contract. But Remix is just a browser, yeah. And it's very, very easy to compile and run smart contracts. It's the easiest for me. When I was learning smart contracts, it was the easiest for me. I don't have to always start compiling and the likes before I write my smart contract. So that is why we are using the JavaScript, and that's why we're going to be using Remix for now. Then when we now understand smart contract itself, when we now want to go into integration and deployment, we can now start looking at tools like AddArt and Truffle to deploy our smart contract and to compile our smart contracts. All right. So thank you very much, guys, and have a wonderful day. If you have any other question, please, on the group chat, drop your questions and we are going to attend to them. Do have a lovely day ahead. Bye, guys.